So welcome everyone. Thank you for joining us for the next 1 hour on our webinar on market of EVs and EV chargers. I'm Hassan Zahir. I'm the Chief Commercial Officer at Power Technology Research. And with me today, I have Mishkat Fatima and Saim Talib. Both of them are the lead analyst on EV chargers research at PTR. A small housekeeping item that every participant's microphone is muted right now. But if you have any questions, please feel free to type them in the chat. We'll take them in a chronological order towards the end. We'll have a sort of Q&A at the end, like 10 minutes Q&A, live Q&A for you guys. So please paste your questions in the chat. We'll take them in the chronological order. So as the question comes up to your mind, just type it there. Some of the quick ones we can answer already, and then the ones that require a bit more detailed explanation, we'll save them for their discussion towards the end. I would like to start today with the brief introduction of Power Technology Research for those of you who do not already know. So we are a specialized market research firm focusing on the power grid and new energy segments. So our clients are basically manufacturers and other players across the value chain of the equipment who utilize the quantitative and qualitative research from us for their strategic decision making, from corporate strategy to business development to product development, for example. That's where our research gets used by our clients most of the time. What are the topics within power grid and new energy that we cover? Essentially, we cover everything inside and outside of the substation and in the industrial facilities, from transformers to switchgear to flexibility transmission systems to HVDC systems. And more the energy transition happening, we are basically also covering the equipment that is interacting with the grid and that is being integrated into the grid as we move forward towards a more decarbonized world. And that includes, of course, the EV charging infrastructure, which is a topic of our presentation today, energy storage, commercial and off-road vehicles, hydrogen as a vector in the power sector, for example. And all of this coverage is basically focused on the equipment most of the time and the software that gets installed in the equipment. With that said, jumping into the topic for today. So this is our agenda to the webinar, but before I jump into the agenda, I want to talk about the importance of EVs and EV chargers. Electric vehicles are coming, they are the future. And traditionally, it has been more of a chicken egg problem. You do not have too many EVs because of the range anxiety, but then on the other hand, the business model of having chargers is not profitable enough to install more chargers. However, today the equation is changing. Today, because of the policies and incentives being put into place, for example, the recent announcement by EU Commission as well, the question really is, would EV chargers be able to catch up with the speed of EVs? And that's one of the questions that we're trying to answer through this webinar as well. But overall, the sector will see enormous growth in the next few years. We believe that both EVs and EV chargers would have a double-digit growth in the next 8 to 10 years around the world. So it's a huge market to enter in. There is significant growth happening over there. And that would be some of the themes that we're discussing today in our webinar. So how would the structure look like? So starting with the brief introduction that I'm talking about right now, I'll hand it off to Saim, who will walk you through the quantitative analysis of EVs, looking at the vehicle electrification trends on light-duty vehicles, trucks, and buses around the world. Then we'll jump into the global EV chargers market overview, and then also looking at the different regions separately, Asia Pacific, Americas, and EMEA. And then from that point on, Mishkat will take over. She will talk about the global EVSE policies and incentives. How are those regulations around EV charging driving the different technological innovations within the chargers from a portfolio perspective? And lastly, we'll have a brief overview of the competitive landscape from a supplier perspective. What's happening over there? What are some of the strategic steps being taken by the suppliers of EV chargers? With that said, I'll hand it off to Saim. If you can please share your screen and start with your section.
Hello, everyone. Good morning, good afternoon. Thank you for the introduction, Hassan. I will now start with my presentation. I will be presenting the quantitative analysis of global and regional EVSE market overview. We will have a look at the current market and future developments around how the trends in charging infrastructure will change in terms of market growth, power, and application segmentation. But before that, let's have a look at the electric vehicles market, which essentially drives the charging infrastructure market and is vital in its understanding. In this slide, we can see the global annual sales of light-duty vehicles. So we have current sales and forecast numbers for passenger electric vehicles on the left side and light commercial vehicles on the right side. The vehicles are further split into battery electric vehicles and plug-in hybrid electric vehicles. So in 2021, we see 5.5 million passenger electric vehicles were sold globally, almost 3 times the number of vehicles that were sold back in 2018. With the increasing number of vehicle models being made available, the sales are expected to rise drastically, and we can expect passenger EV sales to rise north of 30 million by 2030. However, looking at the regional distribution of passenger EV sales, it will remain unchanged for APAC region over the years, which currently sells 50% of electric vehicles globally. Sales in Americas would pick up over time, with EMEA grabbing around 30% of the global passenger EV sales by 2030. Looking at the LCV market, more than 200,000 vehicles were sold globally in 2021, with China selling the most of it, grabbing a 69% market share for APAC region. The rest were being sold in Europe. The total sales for electric light commercial vehicles will be around 2.8 million units in 2030, and the share of EMEA and Americas combined in the global electric LCV sales will increase by more than 50%. So the share for APAC would be 54%, and for EMEA and Americas combined would be 46%. Here we can see the global sales of electric trucks and buses for the years 2021, 2025, and 2030. Electric bus sales in the year 2021 summed up to 91,000. The sales will increase by more than 100% over the next decade. A relatively slow growth is due to the fact that China comprises a major chunk of global bus sales, and with 48% bus sales in the country already being electric, growth in APAC region would be relatively slow. The APAC region had a 93% market share in the global electric bus sales in 2021. Their share will decrease as electrification picks up in the Western Hemisphere. With recent increase in environmental awareness and funding programs for electric commercial vehicles in the Americas, we expect to see a rapid growth in sales in the region as well. The electric truck market is still in its early stages with major deployments only in China at the moment. However, 2021 saw an increasing number of orders placed globally, and with a continuous increase in model availability, the sales will rise exponentially over the decade. The electric truck sales would overtake bus sales by 2025 and achieve global sales of 500,000 by 2030. And by that time, over 50% of global electric truck sales would be in EMEA and Americas regions combined. Looking at the historic EV data, we can see how far we have actually come over the last couple of years. The chart here shows annual sales of EVs on x-axis and the percentage share they make out of the total vehicle market on y-axis. The blue dots here represent sales and share from 2018, while the green ones represent year 2021. It is quite easy to observe the striking progress made in the last couple of years across all key markets. As seen in the chart, almost all major markets had sales share of less than 5% in 2018, all being crammed up in this corner, less than 5%. This has changed significantly over time. Norway leads vehicle electrification globally, increasing its EV sales share by more than double to 85% in the last 3 years. Around 50% of vehicles sold in Sweden and Finland were electric last year. Key markets like UK, France, and Germany have set high electrification targets, and the progress is currently on track, with sales of electric vehicles being 15%, 19%, and 23% respectively in 2021. Although United States is still picking up on the global electrification trends, but with current policies, plans, and incentive programs, the outlook looks positive. Having discussed trends around vehicle electrification, I will now go through an overview of the global EVSE market. As EV markets swell globally, charging infrastructure will need to significantly expand along. Global EVSE market size was worth 3.5 billion US dollars in 2021, more than double of what the market was in 2018. In forecasting the most probable scenario, which we call as the stated policy scenario, forecasts the global market to grow with a CAGR of 23%, reaching an annual revenue of 23 billion in 2030. However, different markets are expected to exceed or fall behind the projected growth, owing to consumer behavior, incentives, and policies. The high and low case scenarios take into account these effects. Changes in prices of chargers over years also play a key role in evaluation of the market. Forecasts are made after carefully evaluating policies and plans from governments, analyzing historical trends, identifying steps taken to implement the plans, and understanding the economic capability of a country. So, under high case scenario, where we expect increased global sales of EV chargers and less decline in charger prices over the years, we see the market reaching 33 billion by 2030. The low case scenario will see the market grow annually by 19% and reach $16 billion value in 2030. As discussed in the previous slide, charger pricing is a key factor in evaluating revenue for the EVSE market. The change in prices of EV chargers vary from country to country depending on a number of factors. One of them would be difference in standards and feature requirements for different countries. Europe has set high standards for electronic components and certain extra feature requirements compared to APAC market, and so the cost of equipment is relatively higher. Involvement of local players in the manufacturing of EV chargers and maturity of the market is another factor that helps in cost reduction. And lastly, the economies of scale. The economic difficulties of fast charging stations threaten to limit the rate of EV adoption in the APAC region. However, China's charging market realized significant economies of scale and dramatically lowered the cost of manufacturing and installing charging stations. Looking at the chart on the left, we can see the massive difference in prices of chargers between China and Western countries for all three charger family categories. There is also an uncertainty in price decline of chargers over the years due to difference in product specificity among countries. Currently, the AC charger market is much more developed than DC chargers, and most of the markets already have locally established players, so lesser price decline is expected over years. For DC chargers, the price decline will be much more significant as more and more players enter the market and demand for these chargers increase. The decline would range from 7 to 14% annual decline for lower power DC chargers and up to 10% for higher power DC chargers. In the next two slides, I will be discussing global public and private EV charger markets separately. We define public charging infrastructure as one which is generally accessible to public. This includes charging points installed on public roads, highways, gas stations, and destination charging, such as supermarkets, car parks, airports, etc. So, global public charging market was valued at 1.4 billion in 2021. The market is set to grow at a steady pace till 2030, reaching $6 billion value at an annual compound growth rate of 18%. Within the public charging segment, DC high power chargers market will grow with the highest growth rate, expecting to generate a 3.3 billion revenue in 2030. The need for quick charging at public locations is the reason for shift to high power charging. Here we categorize DC chargers having power greater than 60 kilowatt under the high power category. The chargers with power less than 60 kilowatt are categorized into DC low power chargers. The low power DC charging sees a reduced growth as it deems fit for certain destination locations only and a choice in emerging markets. The AC charger market is also expected to increase significantly over the years, especially among the underdeveloped markets. Definition of private charging will encompass chargers which are generally not accessible to public. This includes charging points installed in the parking lots of offices. It includes residential charging and charging at depots for electric bus, LCVs, and trucks. The private charging market was estimated at $2.1 billion in 2021. With electrification of transport set to swell, private charging infrastructure market will expand along, reaching 17 billion in 2030 at an annual growth rate of 26%. In the private sector, AC chargers will lead the market in terms of units as well as revenue. The massive electrification of passenger electric vehicles over the next decade would come with installation of AC chargers at homes and workplaces. So by 2030, the AC market is expected to have an annual growth rate of 23% and generate $8.6 billion in revenue annually. A very high growth rate is expected in private DC chargers market. This growth is mainly driven by electrification of fleet applications comprising of electric LCVs, electric buses, and electric trucks. So that was an overview of the global EVSE market. Now we can dive deep and have a look at the regional markets of APAC, EMEA, and Americas. Discussing the APAC market first, the region has been the pioneer of EV charging and mainly owed China for driving the EV penetration rate in the region. In global EV charging station market, the Asia Pacific region had the highest share until 2020, when it occupied 48% of the global market, losing ground to EMEA in 2021 only. Public charging market in the region will reach $2 billion mark by the end of this decade, mainly driven by DC infrastructure. Most of the revenue is being generated by infrastructure installed at destination locations, whereas en route charging, which comprises of chargers installed at highways, public roads, and gas stations, encompasses 1/4 of the market. Public workplace charging is also quite common. In China, there is a policy emphasis on concentrated charging, that is deploying stations in densely populated areas. This emphasis is partly driven by land scarcity and partly intended to drive lower station costs, thereby enabling large growth in public charging infrastructure in crowded cities. Private charging market will increase over 8-fold by 2030 and will mainly be dominated by AC charging due to residential application. The massive charging infrastructure required for fleet electrification in China specifically and generally in the region will drive the private DC charging market. In-depth analysis of individual markets for APAC region shows that in terms of sales of charging points, China currently occupies 90% of the regional market, but its share will decrease over the decade as electrification picks up in other countries. South Korean market is growing at a steady pace. Japan's market has been stagnant for the last couple of years, but with announced plans and policies, outlook looks optimistic. For India, the overall market for charging infrastructure is fragmented and unstructured, owing to segregation in terms of public versus private players. Nevertheless, it is an emerging market and has a strong growth potential. Annual sales of EV chargers is expected to hit 8 billion in the region by 2030. Moving over to the Americas region now, the EVSE market in the region has grown considerably from 2018 to 2021. And even accounting for the negative impacts of COVID on the economies, the market grew by 22% during the period and is expected to grow 35% between 2021 and 2030. With a $1.5 billion estimated market for public charging infrastructure in 2030, high-power DC charging will be the key revenue-generating sector. En-route charges covers 50% of the market, most of anywhere in the world, and a contributing factor for revenue generation from high-speed DC chargers. In private sector, the share of DC charging is expected to rise significantly in North America, owing to the extensive electrification of commercial fleets. The commercial vehicle segment in USA is the largest after China, and with current government's priorities set to electrify fleets, the charging infrastructure market for this segment will be the largest compared to APAC and EMEA countries. The cumulative revenue for DC charging will be 2.8 billion in 2030 and around 2.3 billion for AC. Charger market for employee parking and depots currently comprise of 25% of the private revenue. United States and Canada are key markets for electrification in the region. Annual sales of EV chargers reached 400,000 in 2021, with USA claiming 90% of it, And although the South American EV charging market is set to grow at a steady pace owing to pro-environment policies, 85% of the market will still be held by US and Canada in 2030. Currently, the charging infrastructure in Latin America is mainly owned and operated by automotive OEMs and energy utilities with little or no support from the government. However, electrification policies in the region are on the rise, specifically targeting fleet vehicles. Revenue from these countries would comprise around 10% of the regional EVSE sales by 2030. EMEA region had the highest EVSE market share globally in 2021 with a revenue of 1.6 billion and is expected to lead the global market till 2030. Europe is the key market driving the EVSE market in EMEA. Most of the countries already have significant infrastructure installed. Public EVSE market will increase fivefold by 2030 to 2.4 billion, with targets such as Germany's mandate for all gas stations to provide electric car charging by 2030, and similarly France's announcement that all of its service stations will be equipped with high-power chargers by 2023. These will set the tone for increase in the high-power charging network in the region. Two-thirds of public EVSE revenue currently comes from installation at destination spots. In the private sector, AC chargers currently dominate the market due to residential and workplace charging, and it will remain more or less the same in the future. As fleet electrification speeds up, DC charging market share would see an increase over the years. Region's private EVSE market will peak in 2030 at $7 billion US. Charging infrastructure in Europe is concentrated in few leading markets. Sales in 2021 were no different, which saw 5 countries occupying 75% of the market share. Germany led the sales in 2021 due to extensive incentive programs that would fund public and private charging infrastructure. Annual sales in both France and UK reached 150,000 for the year 2021. These would keep increasing as electrification picks up. Norway and Netherlands currently rank in the top 5 EVSE markets in the region, but will be overtaken by Italy and Spain in the future as these countries boast larger fleet of vehicles and greater population. The total annual charger sales in the region would reach 7 million units by 2030, mainly driven by the private sector. This would be the end of my presentation. I will now pass it on to my colleague Mishkat Fatima to continue with the qualitative part. Thank you, everyone. If you have any questions, please post it in the chat. Thank you.
Thank you, Saim, for the in-depth quantitative analysis of the global EVSE charging infrastructure. And thank you, Hassan, for the lovely introduction. Now that we've seen the forecast for EV chargers in the next few years, it's time to jump into the reasons of why we expect to see these numbers. EV charging infrastructure is mainly driven by policies and incentives, which is why countries with more EV charging funding, incentives, tax subsidies display a more upwards trajectory in their infrastructure in the coming years. So I will now highlight some of the major policies, grants, and incentives in a few of the leading EV markets across the globe and discuss how they help accelerate the growth of EV chargers. So the map you're seeing in front of you has been segmented into 3 categories. The green region represents the market leaders in EV charging. These are those countries which have been actively installing EV chargers in the last 5 to 10 years. The second category is that of emerging markets, which are those countries who are on the track to expanding EV charging infrastructure by introducing new policies and grants, and they have done so in the last couple of years. And these markets are expected to see a steep growth in their infrastructure. And the last category is that of undeveloped countries. These are markets where EV charging is still in its nascent stage. Not a lot of infrastructure has been developed, and we don't see major plans and incentives from the government to promote e-mobility as of yet. But still, we can expect some growth in the next 10 years or so. So the first thing I want to begin with are policies. Now, Europe is striving to be the first climate neutral continent by 2050. And in order to do so, a goal was formalized back in 2019, which is a set of policy initiatives known as the European Green Deal. So, so there was a Fit for 55 package, which had some directives aimed at EV charging infrastructure, and this package has set a minimum binding target for the deployment of EV charging infrastructure. And according to the current proposal, it has mandated all member states to provide at least 1 kilowatt of publicly accessible fast charging power per BEV in the country. Another directive aimed at non-residential buildings requires all buildings with more than 5 parking spaces to install at least one smart charging point and get the rest of the parking spaces ready for EV plugs. And a similar directive has been aimed at residential buildings as well. Now, if we move towards the US, of course, we have the major bipartisan infrastructure plan with a $7.5 billion investment, which has been dedicated to EVSE rebates, incentives, and grants. The plan to build the plan is essentially to build a national network of 500,000 charging stations for EVs across the US. I think there is a total funding of $5 billion over 5 years to strategically deploy these chargers, and which means that each year 1 billion will be allocated, which starts from this year 2022 to 2026. Now that we've discussed these policies, let's take a look at some of the major incentives driving the EV charging market right now. I'll begin with the leading market in the world, which is China. And the main reason behind it is naturally their EV and EV charging friendly policies. So around 44% of the global EV charging infrastructure comes from China. And this is because of their extensive policies and grants, which includes their 14th five-year plan, which supports the development of charging infrastructure in every province for the next 5 years. So not only has it been a global market leader in the past, we also see it leading the market in the future as well. Coming towards Europe, we see Germany, UK, France, and Netherlands as the market leaders, and they represent about 64% of the European market. This is mainly due to incentives like the KfW funding in Germany, which is for private and workplace chargers. We have the Advenir program in France, and $113 million funding for fast charging stations. And then in the UK, we have a £1.9 billion investment for charging infrastructure and consumer incentives. And if we take a look at the developing markets in the APAC, or Asia Pacific, we see India with the government support through the FAME 1 and 2 schemes, and Australia has a future fuel fund, which has an investment of $72 million. In Europe, Austria has been catching up with its neighbor by introducing their grant on EV chargers for home and workplace charger. And this is, I think, was announced by the Federal Ministry of Climate Protection, BMK. And this funding is very similar to the KfW funding. I think it also provides about 900 euros for an 11 kilowatt charger. And then in North America, we see Canada with a $680 million investment through the ZWIP program, which is funding up to 50% of the EVSE project costs. So now that we've summed up all of the EVSE policies and incentives, it's time to discuss the evolution of EV chargers over the years. Now, these days, we often get asked this question on what are the requirements for EV chargers and how certain features vary for different applications of chargers and how the laws and regulations have changed for the installation and operation of chargers. So here, I will discuss all of those regulations that we are seeing and the trends that we are seeing when it comes to the features of EV charging. So harmonized standards for EV chargers has been a point of contention for quite some time now, which is why a lot of regions and countries are introducing regulations on EV charging infrastructure. These mainly apply to public chargers, but in some cases it incorporates private chargers as well. So if we move towards the first one, it is metering. A lot of countries are introducing laws on energy meters for EV chargers. If we talk about Germany in specific, it has the calibration law, which requires all charging devices to provide a transparent billing system. Similarly, in UK, Netherlands, and France, we have regulations that require intelligent metering systems. Now, these intelligent metering systems must be able to record information about the energy consumption of the charging point and also transmit this data back to a central system. The next one is smart charging. A lot of countries are introducing regulations on public chargers to be smart, which means that it must be able to allow the data exchange between each charging point as well as real-time monitoring of the status of all charging points. And how this has been mandated is that the KfW funding scheme in Germany and the housing charger schemes in UK and tax subsidies in Belgium, all of these grants and incentives have a requirement that all chargers must be smart. So in order to achieve those grants or receive those grants, users need to install smart chargers. Which also brings me to my third point, which is that another requirement which has been mandated by these policies and incentives is that the chargers must be provided by renewable energy, and which is a very fair point, because if we are introducing new EVs and putting in these charging infrastructure, it is essentially to reduce the amount of emissions. And what good is it if all those chargers are powered by electricity generated through fossil fuel? So that's why renewable energy is a very ongoing strict regulation that has been put into place in a lot of the countries. And then next one is payment. So there are a lot of countries which have introduced a very specific payment method for EV charging. And if we talk about Germany, it has recently introduced a new but much contested regulation that requires all future charging points to have a debit or credit card reader. And we also have similar requirements in other countries as well across Europe, which includes Netherlands and UK, and then also in the US. And the next one we want to talk about is load management. Now, this is a very important feature that has been coming into play as part of the regulations. In countries like Germany, Netherlands, and UK, these countries have mandated the integration of load management system in parking spaces. So usually there is a minimum criteria set which requires that if there are more than 5 or in some case 3 chargers installed in a particular parking space, it is necessary to have an integrated load management system. And rightfully so, as this feature is essential to keep the network from overloading and for smooth charging of multiple EVs simultaneously. Moving on to the next one, we have building regulations. as I spoke about earlier in the EU Green Deal. Similar regulations are coming into play in a lot of countries across Europe and also in other regions of the world. In the UK, for example, a new regulation has been set into place which requires all new buildings to be equipped with charging points. And surprisingly, even in a state in India, it has been mandated that all new company buildings will require to install charging points. And the last point that I want to discuss here, it basically encompasses most of what we have discussed on this slide. It is obvious that if we want our chargers to be smart, have an intelligent metering system and load management feature, so naturally it will also require a very high uptime ratio. This goes especially for public chargers. So there are also a lot of regulations ongoing for a minimum uptime of these chargers. For example, in the US, there is a minimum requirement of 97% uptime for public chargers funded through the bipartisan infrastructure law. Now that we've summed up most of the regulations we can currently find on EV charging, it is time to move on to the technology trends that we can expect in the future. So the first one I want to talk about is the DC wall box. So there's a general shift ongoing towards fast charging, and though presently most of the EVs are charged using AC chargers, and out of the hundreds of EV models which are present right now, only 10 or less than 10 are compatible with the 22 kilowatt AC charging, and this is because of the limitation of their onboard charger. So DC wall boxes, which are usually have a capacity between 0 to 30 kilowatt and which are usually 24 kilowatt, they make up for this gap. And this is the reason for this is that they allow for faster charging, because DC charger naturally does not require a converter to be installed in the charge. So they allow for faster charging, and they can also be easily deployed in shared parking spaces, retail shops, and workplaces. So we can also expect an increase in these DC wall boxes in the future. The next one is the V2G technology. So this cutting edge feature is, or V2G is basically vehicle to grid. So this is also something that which is found in most of the DC wall boxes I just discussed. So what it essentially does is that it allows the users and utilities to pull energy from the car battery when energy systems are more strained, and therefore it balances out the variations in energy production and consumption. As of now, more than 7,000 V2G enabled chargers have been installed globally, and more than 20 manufacturers have introduced this feature equipped with their chargers. Some of the names that I can think of are Magnum Cap, Hitachi, and EV Tech. But still these projects are in their pilot phase, and there is a lack of the availability of V2G compatible EV models. So this is why these factors are still inhibiting the growth for V2G adoption. But as new models will come in the future, we can see an increase in this feature in the coming years. The next technology trend we're seeing, when it comes to EV charging, is wireless charging. Now, wireless charging, there are two kinds of wireless charging. One is dynamic and one is static. So dynamic is that electric cars can charge while on the road. But this is not that common. Mostly static is used. So this concept is based on the inductive charging of EVs through plates which are installed in the road in parking spaces. So because it's wireless, so it relieves the task of plugging in the vehicle. A lot of pilot projects for buses have been started. which includes projects by Vitricity in the US and Europe, and there is a company called Wave, which has introduced a pilot project for wireless charging. Then we have Electrion in Europe. So, and this wireless charging is mostly applicable to vehicles with long and fixed routes, so essentially public transport. So if we talk about taxis, fleet vehicles, or intracity trucks, so this technology will be more useful for this application of chargers. However, it is still being tested out, and we are yet to see whether this trend will take over in the next few years or not. And the last trend I want to talk about is MCS, megawatt charging system. Now, this is expected to become a future charging standard for heavy commercial vehicles. So the CCS initiative CHARIN recently demonstrated this system, the MCS, for the first time at the Electric Vehicle Symposium in Oslo. And the prototype designed for this pilot project will enable charging up to 3.7 megawatts. So it's still being tested out, and the prototype has been designed for the pilot projects, but it could take over, and it is likely, if it works out, it is likely to become a standard for high commercial vehicles, heavy commercial vehicles, sorry. So I think with that, I sum up all the technology trends that we're seeing and all the regulations that we're seeing. I think I can now finally discuss the last thing in this presentation, which is the competitive landscape for EV charging. So the last few years have seen a lot of companies entering the EV charging business, and even some local EV charging startups have sprung up too, which brings me to my first point, which is diversification of business. A lot of oil companies and energy retailers have decided to tap into this e-mobility market because clearly it is emerging as a very lucrative alternative to their oil business. And how they're doing so is that we see a lot of acquisitions of charging infrastructure providing companies. And the reason for that is that the acquisition of these companies allows them operational control and ownership of a significant number of existing charging points. And it also adds a very new and growing consumer base to their business. So if I speak about a few examples of such companies which have acquired charging infrastructure providers, includes Total, which is now called Total Energies. So it acquired the G2 Mobility in France, and then Source London in the UK. Shell acquired New Motion and Ubitricity. Enel acquired E-Motorworks and now has its own separate e-mobility dedicated entity called Enel X. We know that NG acquired EVBox. So with these acquisitions, these energy retailers and utilities are able to diversify their product portfolio, and they can enter new markets where they aren't currently active. Now, if we move on to the next trend that we're seeing when it comes to the competitive landscape, is that smaller companies that own public charging infrastructure are being acquired by big utilities. And the reason for this is that these companies find it difficult to operate chargers in areas where there is low utilization rate. And of course, this becomes less profitable to them. So these bigger companies have a higher tolerance level for losses and can manage these companies better. So which is why we see a lot of these acquisitions coming into play. The next thing I want to talk about here is the 360-degree service concept. Now, this concept is based on on companies trying to, to put it simply, companies trying to become an all-rounder in the EVSE business. So what they want to do is they want to manufacture chargers, manage chargers, operate chargers, and even design the software management system for the chargers. So basically act as a manufacturer, act as a CPO, and even as an EMSP. Of course, this all-rounder technique allows them to enter more and more markets, increase their global assets, and expand their business. So we see this trend a lot when it comes to acquisitions in the EV charging industry. And a few examples of this are that Eaton acquired Green Motion, and ABB partnered with Charge Lab. And a very recent acquisition we know of is that ChargePoint, which is a US-based company, acquired Has2Be, which is a software provider for chargers in Europe. So what's happening here is that these companies are acquiring these charging companies, and it's allowing them to gain access of more and more chargers and expand their network globally. Now, if I move on to the next trend, the third trend, which is it is of the companies going public. The reason for that is that by going public, they're able to increase their product portfolio, because going public provides them more capital to invest in the company, and it also allows them to expand their global footprint. So there are two methods of going public. One is the SPAC or SPAC route, which is the special purpose acquisition company deals, which allow the companies to go public. Another is the very traditional method, which is the IPO. Basically, SPAC deal is currently what we're seeing is that SPAC deal is preferred over IPO because there are lesser regulations. Some examples of this are that ChargePoint, EVBox, Wallbox, and Tritium are companies that have opted for the SPAC route to go public, and even ABB and some small companies are intending on going public via the IPO route soon. Fastned and Blink Charging already went public in 2014 and 2018 through the IPO route. So these are a few examples that we know of. And then if we move on to the last trend we see in the EVSE companies is globalization. Now, this term refers to the companies entering new markets in order to increase their global assets. A lot of companies are making strategic attempts to expand their business by tapping into new markets, and they're doing so with the help of new partnerships, mergers, and acquisitions. To state a few examples, we have ABB acquiring Charge which is in China, and then ABB recently acquired Numosity, which is in India. So obviously they want to deepen their footprint in different regions and expand their business instead of having a very localized business. And another example of this is that Blink Charging, which is a US-based CPO, it recently acquired the European EV charging operator Blue Corner. And Blue Corner already had a network of 7,000 charging points in Western Europe. And just one acquisition gave Blink Charging immediate control of those 7,000 charging points in Europe. So all this globalization has made it a lot easier for these companies to expand their business or enter new markets. And yeah, we see the EVSE market going towards consolidation with the help of these trends. So that was all for the competitive landscape. I will now hand it over to Hassan.
Perfect. Thank you so much, Saim and Mishkat, for your presentation. Very insightful. I already see a lot of questions in the chat as well. Maybe we can already start one by one with these questions in the chronological order to be answered by you guys. So the first one is from Aaron, if I'm pronouncing the name correct. Change in consumer behavior or favorable government regulation, which is more pivotal in driving the EV adoption rate?
So I think I can answer that question. So it's government regulations, plans, and policies are basically at the crux of driving the EV adoption rate. In the case of many European countries, and even if we consider US, Canada, China, it's the same case. So in these countries, the governments have rigorously incentivized EVs and its charging infrastructure. But
Mhm,
however, the consumer behavior can be a limiting factor as government regulations and policies are mainly driven by consumer behavior. So currently consumers are already inclined to buy EVs, but they want improvements in range, the initial cost of these vehicles, and the choice of vehicles that they have at the moment. So this compels the governments to bring in subsidies, set new targets, bring in regulations to compel automotive OEMs to conduct further research and development for introducing more EVs and more with better technologies and better
mhm.
battery technologies. However,
Okay.
I would conclude it by saying that neither one can alone drive the adoption rate up. Favorable
Mhm.
government regulations promote consumer behavior, and on the other hand, enhanced consumer behavior compel governments to bring in better EV policies.
Going back to another chicken egg
Yeah,
problem in the
yeah.
domain. So we have another question from Oscar that says in slide 12 and 13, global private charger market for 2030 has been shown to be three times greater than public charger market and shows an increased growth comparatively. What is the reason behind this? If you maybe want to go to slide 12 and 13 for everyone to see as well the questions, and then you can please answer that.
I think I'll answer this question as well.
Mm-hmm.
So So by definition, the private charger market consists of chargers that are installed for residential use. These are the chargers. There are chargers installed at workplaces for employees, chargers installed at depots, at loading bays for electric LCVs, trucks, and buses. So this market is directly driven by vehicle electrification. And as vehicle electrification picks up, the private charger market grows in a similar fashion. Currently, the residential application is the largest contributor to the private charging sector, with around 60% of the private charging revenue pouring in from this application. So, and also the fleet electrification keeps increasing. As the fleet electrification keeps increasing, the demand for chargers required to charge those vehicles will swell along. On the
Mm-hmm.
other hand, if we see the public charging market, public charger market's growth, it's although projected to grow at an exponential rate, but it is
Mm-hmm.
bounded by certain factors such as demography, because
Mm-hmm.
the public charges need to be placed at a certain distance, and at certain locations they cannot all be cramped up. There's also the factor of lower utilization of these public charges, because the companies, the businesses, the CPOs that are putting these charges, they need to get their money back, and if they keep on adding more and more charges, the utilization rates they do not go up. So and lastly, there's these for public charges, especially for the DC charges, there's this factor of utility upgrades. So who is going to pay for all these utility upgrades if they want to invest in the charges? So this limits, although limits the public charging market compared to the private charging market, because private charging market does not have any bounds. It is mostly the investment come from the private players. So that is why we see a larger growth in the private market.
Okay, moving quickly to the next question from Stephen. Majority of the population in most countries do not own a private driveway, and a lot of countries, like in the Middle East, people are known to have more than one car per household. How do you translate the interest of this population to have an EV and to be able to charge their car into actual demand, given that they don't have a proper parking space? I think it's more a question on the methodology of sizing the market of chargers, if you guys want to answer that.
Yeah, I'll take that over, Hassan. Thank you.
Mm-hmm.
So yes, a very good question in the sense that it's really difficult for people living in apartments to charge their car. But again, as I mentioned earlier in the presentation, that policies play a huge role. We talked about the EU Green Deal with its policies for or regulations on buildings and installing charge points in the UK, and then there are regulations on having smart charge points for every building. Even in India, there is a regulation on all commercial buildings to install charge points. So these play a huge role. So as more and more policies will be placed, and these countries, obviously Middle East, even though a very developed economy, is still lags behind when it comes to the EV or EV market. So yeah, I think these countries need to implement such policies or put them into place and install more and more on-street chargers or chargers in building, and regulations on buildings to install chargers. So an example that I can think of off the top of my head is a plan with a partnership Shell made with Ubitricity to install 50,000 charge points in the UK. So naturally, like, we can see a boom in EV chargers, and it's also making these public charging points accessible to those living in buildings who do not have a private parking space.
Yeah, I also saw that in Middle East as well, UAE, there was a recent announcement between Siemens and the Energy Ministry that they're going to collaborate to put more public charging infrastructure in this region as well. So we see some growth over here. Looking at the time very quickly, next question from Sebastian on the V2G topic. How do you see the implementation of bidirectional charging to allow for vehicle-to-grid applications, as this would allow for better capacity management and interoperability behind the meter, and in some cases acting as a storage for on-site solar? Do you see policies supporting this any further in the future?
So yes, as of yet, as I mentioned earlier as well, it's still in its pilot phase. This technology is still being tested out. So the feasibility of this is yet to be discovered, and still there is a lot of research being done. And now we have around 7,000 chargers installed globally. So once, obviously, if they're going to be successful and they work out, I do see policies being put into place that that require V2G chargers. Obviously, it will be a huge support to the grid as well. So yeah, I do see this growing in the future.
Okay, and then we have one last question from Ali. As mentioned in the technology trends, the DC charging is limited up to 20 kilowatt. So by using a DC wall box, we can extend this kilowatt to 24 kilowatts.
I'm sorry. I think from what I understand for this question is that DC wall boxes have charging capacity up to 24 kilowatt. That's the usual case. It's not 20 kilowatts. It's 24 kilowatt, and we see that from manufacturers like ABB and IES Energy. So these manufacturers are putting out chargers, DC wall boxes, which have up to 24 kilowatts. And yes, it will allow faster charging up to 24 kilowatt. DC chargers, obviously, they don't require a converter in the car either. So yes, it will allow for faster charging.
All right. I think with that, we have reached the end of time and end of questions as well. I would like to thank everyone once again for joining us today for this webinar. It was really good to see some familiar faces as well. And yeah, looking forward to have you in the future versions of some of the research that we share with our webinars. And if you have any questions in the follow-up as well, the recording would be available. Please feel free to shoot any one of us the email, and we'll be happy to answer those at the later point in time for you as well. Have a nice day, and yeah, thank you so much.
Have a nice day, guys. Thank you.
A nice day. Thank you.